Hello and welcome back. Let's give this another shot here. Diagnosing. We're continuing the diagnosis of this. Let's turn it on. Why don't we have our trusty. Oh, help if I plugged it back in, wouldn't it? Whatsoever did I do there? And I thought we were ready to go. I think I have to, on OBS, when I thought I had it set to deactivate when not showing. So let's see why. Oh, okay. Let's try that. I would think that would work. There we are. So we're diagnosing this faulty display, and hopefully when I plug this in this way it'll just turn on. I suspect it will. Yeah, and it's still got the error code. Where's my trusty filtering bag? That one should do all right. Not as well as the foil bag here. So here we can see clearly that it's definitely not correct, and we can see those glowing segments. Just looking back from yesterday when I was working on this, and mostly yesterday I was working on getting my setup set up so that this I can stream this, which is new to me. One of the things I added yesterday that I didn't have going on is I now have the scope set, so let's make sure you're seeing the scope. And yes, you are. We can turn off, I guess we could turn on, we could probably shrinkify these tabs a bit. Yeah, so we should be able to see the scope. So what we really need to do though is hook up the pins of, now that's interesting. Boy, nothing's working today. Okay, there we go. What we need to do is hook up the pins to this shift register. So this is serial in, parallel out. Here's the kind of the logic symbol of it. We have a clear, which I presume is being used. We have a clock, which I will be sure is being used. And then we have an A and a B, but I presume only one of those is being used. So let's disconnect this from the... I just need to keep making sure you guys can see what I'm showing. There we go. Let's disconnect this from power so we don't mess anything up while we're playing around with it. Ooh, those wires are not very well terminated in there, so too much bendy and those wires are going to start breaking and shorting. That is not a good situation right there at all. So I need to be really careful about that. Not cavalier, but careful. Yeah, I think I will use the old pry method to get that out. Yeah, pretty soon it's going to be another failure, and I should probably check that to make sure that's not the failure. But my belief is that this connector, I'm quite sure of this, by the way, because P Horde on GitHub has a I'm just going to power it down. P Horde has a repo whereby he has decoded all the commands. And this does say in here, if we can see it on this thing, there's a 5 volt, there's a ground, there's a T for TX and R for RX, and then there are 3, I think they call them HS1, 2, and 3 kind of GPIO or IO pins. So pretty sure this is just serial communication over to this PIC chip, this PIC micro. It's not a PIC, it's a Freescale microcontroller over here, and then the shift register. So right now what I want to do is I want to see if the shift register is connected, what lines of the shift register are connected. So really what I care about is if A and B are both being used, or if one of them is just permanently pulled high. So let's check that first. I know for certain, because of the markings, and I've also played around with it, that this is the 5-volt pin and this is ground. So if I were to look here, I'm looking on the data sheet, which you can't see. A is pin 1, B is pin 2. This, of course, the dimple tells us that this is pin 1. So let's go here to 5 volts. Let's get the multimeter on, which you can't see, in continuity mode. I'll hope to get that showing somehow or another, whether it's through some awesomeness or just a camera on it, but I'll hope to get the multimeter showing on my display here at some point. So here's 5 volts. And I'm not seeing A as connected 5 volts, nor is B. And we'll just check ground. But that shouldn't have been the case, because that would keep it always off, so that shouldn't have worked. So maybe they are using A and B. And we could look to see where those might go, but this camera is not the highest resolution. So I'm not sure this is the best idea to do here. I mean, the easy way to do that would be to take pin A and just search around on the microcontroller. So we do have one here. So that's A. And then B, look at that focus. B is next door. So they are using A and B. That's interesting. No, they're not. So A and B are common. So they're not tied to 5 volts, they're just tied together. So here's A again. Let's get on this microcontroller pin right there. And B is here. So those two are just tied together. And I think I can see the trace underneath. I think it goes to this via right here. Yeah. So that's A and B. All right. So then we need to just see if clear is used. Let's go, I presume it is, but let's see if it is. So clear is on pin 9. So there's 7, 8, 9. So that's 9. And we'll just look at right around this one. No. Make sure I'm staying on 9. And clear is not clear, so I'm going to think that it would be, am I still on it? Yeah. So I would think it's attached to, nope, I don't know where it's going. Clear, it could just be not used, I guess. Then let's just find clock, which that's pin 8 right here, and that absolutely has to go to the microcontroller. There it is. I don't really care which pin it is, I just want to make sure. There it is. We have an enable, which is 10, so 8, 9, 10, this one. This is so exciting. Let's see here. Enable. No, that's not enable. We don't have an enable. We have an output A, B, C, D, E, F, G, H. Let's get you guys looking at that too. We have output A, B, C, D. I hope you guys see my mouse. Do you not see my mouse? Let's just make sure we're capturing the... Oh, we are capturing the cursor. All right, there we go. A, B, input. So that's here. And then we have A, B, C, D, E, F, G, H. We do not have an enable, so we're going to shift on the clock. I'm surprised the reset isn't connected because I don't really see how it resets. So that's kind of weird, but curiosity to me at least. So clear should be high, should be at least pulled high. And yeah, so what we're going to do is get the oscilloscope on the clock and the A line and see what that looks like. So let's go back to our other camera. And we've got some of these Agilently mini grabbers. And we're going to go on, I'm going to relook at what the pin numbers are. Pin number 1 or 2 will give us the A and B, and remember those are common together, so no biggie which one we get, but we're just going to get 1 by convention. Alright, and then we'll get clock, which is pin 8, which is way over here on the obverse. Okay, here's that guy. And then we'll take some DuPont jumpers. We'll get on here. And we'll take another DuPont jumper. And we'll get over here. I don't find a lot of these DuPont jumpers to be awesome, so like it is not really staying pressed on that square pin at all. So, you know, this is one of those things where I know they're like 80 cents for a billion of them on AliExpress, but I think I'd pay like $20 for a really good ones that the connectors actually work, because I'd save that in frustration one of these things falls off. All right. I picked 2 green ones. Doof. All right, here's a white one. Let's try a white one. I guess if I were smarter, I'd take the ones that don't work very well and just throw them in the trash. All right, so 8 we said was clocks. That's the white one, and 1 is A. So let's take some scope probes. Oh, we wanted one more on ground. We want to get ground connected up here also. So I wonder if we can. I wonder if we could just press on that pin in the header right there. Probably not. We'll just to be safe, we'll do it this way. All right, got another little mini grabber. If the tool works, use it everywhere. All right, so blue is going to be ground. See, they just don't stick very well to there. It's not really. I find that inordinately frustrating. Okay. So we'll take the scope probe here, hook this to ground. We'll use yellow as channel 1. We'll use that for the A signal. And just to double check myself, that's pin 1, which is this green one. So we'll hook that up to A. And then we'll take the clock signal and we'll hook that up to B. And let's go over to the oscilloscope. All right. And let's take probe 1 and we'll label that. And we'll call it A is going to be, let's just double check myself here. 1 is A, and that's A. And let's go to probe B. Oh, there it is. We'll label that CLK. All right. So if I label them, why does it still say C1, C2, C1, C2? Why doesn't it say that right there? It seems weird to me. Make sure both of these are set on 10x. Okay. I hope I switch this over to video. I did not. I'm fired. I forgot to show you what I've got going on the scope. There we go. Okay, so I've got the probe, C-tube probe set to 10x, and I've got it labeled as clock, and I've got the C1 probe here labeled as A. It is also 10x. They're both DC coupled. Yeah. So let's get rid of that, and we'll get rid of that. We can't put the ground there. We're going to be attached there. Doi. Can't put the ground on this connector. We're going to attach that. So we'll look back at the data sheet for the 74HC164, and we'll say that ground is pin 7. So we'll just come over here to pin 7 for ground. And then we'll come back into here for the connection. I do have the crimpers and terminals for this JST connector. I don't remember the series for it, but I know I've done it recently, so I do have the crimpers and terminals for that if things go very wrong. Okay, so let's look at our scopy again. A little bit of cleanup. And let's plug it in. And we get a signal. A messy one, but a signal. So, let's take our C1 and we'll bring that down a bit. And we'll take our channel 2 and bring that down a bit. Let's look at our trigger settings. See, again, I don't know why the labels don't carry through everything. That just seems so weird. Like, I don't understand that. Is that something I'm doing, that I don't see the labels everywhere? Look, my clock's off. It should be 8:31. Yeah. Yeah, I think we'll ask ChatGPT, see what it says. Bummer. Okay. Yeah. Well, there's my clock. Let's get a trigger set here. I don't even see the labels anywhere. They're kind of pointless. Channel 2 is our clock, and that's really what we want to trigger on. So let's go back to trigger. Channel 2. Set our trigger level. Fairly clean trigger. Okay. Do I have persistence on? Single. Single. We're supposed to be triggering on C2, right? So why isn't it capturing longer? Trigger. Acquire. Can we acquire a sequence of, like, we want to capture a bunch of them. the little bursts. So this is persistence of vision right in here, in between these clocks. Let's get two of them on the screen. That's why I was having trouble. Okie doke. So there's one burst, and there is the next, and this is where the digit is staying on. So the interesting thing would be to put one more channel on there and look at the output that turns on a digit, so we'd only see, say, digit A. That would be a pattern situation. Unfortunately, I don't have the time to do that just now, so I'm going to stop this and we'll pick it up later.